Hi everyone. Good morning. Um, Today we are going to be sharing about SelfCAD and welcome to our event. If you're watching the replay, then please also feel free to drop in the comments and say hi. Today's topic will be on vertical alignment for elementary, middle school, and high school. So my name is Irish Ann. I am SelfCAD's marketing manager, and I will be your moderator today. And let me introduce our other speakers. First, we have Jennifer, our instructional designer and curriculum developer. And we also have Aaron, our founder and president. So, yeah, let me also give you an overview of what we'll be walking you through today. First, our market trends. We will discuss what is changing in the 3D printing and 3D modeling market. Next is how we bridge the gap through vertical alignment, and specifically how you can integrate SelfCAD in your curriculum and which businesses are currently using SelfCAD. Then we'll head on over to give you an overview of the software itself, and I will be walking you through pricing and budget considerations. So without further ado, let me hand over the floor to Jennifer to start the presentation.
Thank you so much. So what is changing in the market? Let's talk about what's happening in 3D printing and 3D modeling. Experts are saying the slow adoption of 3D printing is mostly caused by the knowledge and skills gap. It's a fairly new technology, and we're finding that many professionals are lacking skills and they don't have the knowledge they need to make the most of the technology. Companies are wanting to have more speed and accuracy. They're wanting to utilize rapid prototyping. Lots of organizations are wanting to bring 3D printing in-house. They are having a more focus on designing, and they want to be able to print spare parts. They are using 3D printing for hybrid manufacturing, and they're expanding more and more into the aspects of 3D modeling for the use of digital twins. So I just want to give you a brief overview of what's happening in the market, what the market trends are. In 2023, it was estimated to reach over 20 billion. It's projected to reach even more at 88.28 billion by 2030, and that's a compound annual growth rate of over 23%. So we know the market is growing, and we see that this trend and this new technology is bringing quite a few manufacturing issues, especially when it comes to design. For many engineers entering the field of manufacturing, 3D printing was not a focus in their education. We can also talk about other industries and other companies who are wanting to convert their digital assets from 2D to 3D for obvious reasons. Many of those professionals in regard to 3D printing need to create digital assets for virtual reality and graphic design, digital communications, fashion, real estate, education, interior design, and even healthcare. This has created a demand in 3D printing and modeling, and as it becomes more and more established, these skills and training need to be further integrated into all levels of education. Another aspect worth highlighting is that students who are wanting a high-tech career are strongly influenced by their classroom experiences. 57% of boys and 68% of girls who have chosen a high-tech career say they were inspired by one or more events or one classroom in their middle school or high school. The knowledge and skills gap becomes more apparent in the context of STEM education because there is still a need to integrate 3D design and modeling into our existing learning programs. It seems obvious to me that early exposure is key. Now let's talk about some of the challenges you might be facing or thinking about. Currently, your students need to switch from various 3D modeling and 3D printing apps. And as their skills advance from elementary to middle school and even into high school, teachers need to create their curriculum from scratch. It's time consuming, and it may also create a situation where teachers are expected to write curriculum at the same time as teaching it. This causes frustration and burnout. Whenever a switch or transition to a new software is required, districts need to purchase new software and new curriculum while they onboard teachers and students and set up systems from scratch for each level of education: beginner, intermediate, and advanced. The tech that students learn in the classroom isn't necessarily what they're using in the workplace. Additionally, projects in class may not be good enough to be considered industry relevant. Capstone projects should be connected to industries. They must have real-world applications if they want to put them in their professional design portfolio. Without curriculum alignment or internships, how do they get the industry experience? So how do we bridge the gap? SelfCAD helps students acquire career-ready skills. Today, I'm going to introduce you to the idea of 3D modeling and vertical alignment. This is our solution for bridging the gap that we're discussing today. As students progress through their education, it becomes increasingly important to equip them with the essential skills they need to prepare for the future. SelfCAD is a user-friendly 3D modeling and design software that is suitable for ages 10 and up. It offers a seamless transition from elementary to middle school and high school with possible internships to help students build a portfolio. Contact me for more information if you're interested in your specific alignment needs. Vertical alignment, this is what vertical alignment looks like. Once students begin using SelfCAD in elementary, they can continue using the same software as they progress to middle school and even through their high school years. So how do we introduce 3D modeling and printing to students? Here are some exciting opportunities to enhance your existing program and to incorporate 3D design into what you're already doing. First of all, we're going to show you the easiest way to incorporate SelfCAD, and that is through stations and rotations for elementary students. Since teachers are already doing this, they can set up a couple of computers in their rotation, set up an interactive tutorial which walks the students through step by step, and that gives them an opportunity to create something from scratch. And they have this feeling of accomplishment. Some of these designs only require 20 minutes. It's a great opportunity for them to learn 3D design while in their rotations. Other opportunities to enrich would be after-school programs, as well as summer camps, makerspace, STEM night. Why not do a mini challenge? Here are two examples from our curriculum, just to give you an idea of what we have. We have two students that are working together. One student makes something in real life. The other student translates that design into 3D software. The first example you see here is Play-Doh. And the second example is a wooden block castle. So we're going to go into secondary students. And I've listed a few ways that you can implement the curriculum for these students. This can be either self-paced, teacher-led. It's all project-based learning. You can incorporate it into many of your CTE courses that you already have. There's definitely some overlap here. Why not have an elective night? Why don't you have a showcase with some computers already set up? See how your students respond. What's the interest, and maybe go from there. So I also want to mention again that the demand for CAD professionals has reached an all-time high. And thanks to the rapid expansion of 3D modeling across various industries, we need to consider that what are we doing to bridge the gap, and how are we incorporating this into our existing learning programs? So here are a couple of CTE courses that you could maybe focus a little bit more on 3D modeling and CAD. And those domains could be college and career exploration, architecture, construction, digital arts, AV communications, and digital communications. Of course, we have science, technology, engineering, and mathematics. So let's dive a little bit deeper into what we're talking about and the benefits of 3D design and how we incorporate that so that it supports learning. We know that 3D visuals are important for special populations. Visualization of core concepts and introducing 3D modeling to teachers can really reinforce foundational concepts. For example, the science models I have for you here, there are things that you would normally create as a craft. Maybe a student or teacher would have to buy the materials and then they would build it. So these all can be replaced with 3D lessons, and these have been created for you. And by implementing 3D projects, we can introduce students to the world of STEM through multiple subject areas. So I really don't want anybody to leave here today without at least hearing about our cross-curricular lessons. Here we have a lot of biology models. And as you know, these are very complex, but really fascinating, interesting way to introduce cross-curricular and 3D modeling. So we have created a few of these that you can also incorporate in your existing programs. And I'm really proud to say that we are growing and we're expanding. We're adding more interactive tutorials to be used by educators. So this is just a taste of what the 3D models and curriculum that we have. All of these things can be 3D printed. Welcome to Geometry in Real Life. Math teachers, you're going to love this. So we have found a way to teach math concepts using 3D design. So teaching geometry without visuals can be difficult. So here are some three-dimensional shapes that I'd like to introduce you to if you don't already know. These are three-dimensional shapes that have 4 sides, 6 edges, 4 vertices, and it's called a tetrahedron. It also has a three-dimensional shape and 4 triangular faces. We also have a spiral of Theodorus, also referred to as the square root spiral or the Pythagorean spiral. It's constructed with a continuous right angle. So here are just a few things to give you an idea of what's, in Unit 3. I'm going to go on and tell you a little bit more about Unit 3 and these math concepts that we're talking about. So how do you measure volume? What is spatial reasoning? How do we practice visualization skills in math? There are so many things that I could tell you about in regard to our curriculum. It's project-based, it's cross-curricular, it supports multiple populations for different types of learning. We have capstone projects, we have many challenges that you can use for 3D printing at all ages. This can be applied to many careers and many industries. So if you are at the district level, I feel pretty strongly that this is an all-in-one solution for you. Not only is it early exposure and vertical alignment, but it's also scalable so that you can have either teacher-led or self-paced with little or no planning. I'm going to hand the floor over to Aaron, who's going to talk more about the software and which industries are currently using SelfCAD.
Hello, everyone. Okay, so first of all, about which businesses are currently using SelfCAD. The main thing is we start is with 3D printing, which is obvious. That's something that's across many industries. 3D printing is often considered hobbyist, but there's also a lot of prototyping and actual final production as well. The reason SelfCAD is used for 3D printing is multiple reasons, depending on the industry. So if we talk about hobbyists, one of the main advantages is you can import anything, go to Thingiverse, for example, and you can edit them and mix them and remix and do whatever you need to do with it. But even more professionals, the idea is in SelfCAD that we make sure to create everything manifold, which is a requirement for 3D printing. And we also have options to fix broken geometries. And finally, we have a built-in FDM slicer. So if you think about what the 3D printing aspect of SelfCAD is, kind of having a 3D modeling app, plus like mesh mixer, plus like Corel slicer, all in one package. But SelfCAD is much more than that. It's also being used a lot in product design. And product design requires some more advanced tools. Some of them are more artistic type of tools, and some of them more technical tools, for example, lofting and revolve, all this type of stuff often used, and obviously rendering as well. So 3D modeling obviously is always just a means to exporting. So you can export them as a geometry 3D printing, or you can export them as a rendered image, which is often the case of product design, and sometimes also just the actual object themselves, print as a prototype. When it comes to engineering, SelfCAD is used differently. It's used more about low-end engineering, not really complex industrial use cases, because we're not parametric. But it's used a lot by basic planning, early stage engineering, which is very difficult, time consuming to do something with a parametric modeling application. So it's really easy to just get started in SelfCAD, and that's where it's used. So now let's go back to the idea of editing. So in the first slide, I said the idea about modeling. And when we consider modeling, the term is used, obviously, a lot of things, but usually what we consider modeling is creating something from scratch or general basic remixing and so on. But SelfCAD actually is also a very powerful editor. And that comes with the territory that we are a polygon-based modeling applications. And the same thing I said before, you can import something with Thingiverse, but you can also import anything that is scanned in. And actually, this is where SelfCAD is used the most. And if you consider like Fortune 500 companies, what they take the most advantage of SelfCAD is this part, the editing part. So you can scan in. We don't obviously know how people use our software. What we do know when people interact with our customer support, our customer support is next to none. I mean, it's really amazing, the feedback we have. And we have a lot of companies reach out to us with specific use cases. And many of them have different scanning use cases. And we have done with prosthetics, we have done with surgeons, and we have done with dentistry, as you can see over here, an example. We have actually a big company that used to use industry-specific software for dentistry, whatever, I cannot disclose exactly what they're doing, but they used to pay upwards to $20,000 for their software, and now they switch completely over to SelfCAD with a fraction of the cost, just a few $100s for an entire team. And basically, they can do everything plus some advantages that they cannot do in the industry-specific software. And when it comes to biology, I remember a use case. Actually, a doctor asked me, I'm not sure if it was training or for real, but kind of creating these extensions, lofting and kind of like stents, building and these type of stuff. But I'm not sure if it's education or real use case. But if you move to the next slide, this is an example where we have actually someone that shared with us, which is a professor, science professor, that used SelfCAD to teach basically biometrical models and so on. And the main advantage they explained to us is the ease of use, but also more importantly for them was the mixture of artistic and technical tools. So you can find a lot of sculpting tools out there, but a mixture of sculpting and 3D modeling in one package, it was for them a great advantage because they can build the basic models using the technical modeling tools, and then they can touch it up and play with the sculpting. And this integration was great for them, so they developed the entire curriculum based on using SelfCAD. Okay, so now about the software itself. So SelfCAD prides itself as being the simplest, fully functional software, fully featured software. The question is, like, why is it so simple? Everyone obviously can claim to be intuitive, to be easy. So I would like to tell you three main things, factual things that actually make SelfCAD really simple. So the first thing is obviously UX. That's debatable. Everyone can say they have an easy UX, but I'll explain you what SelfCAD UX looks like. So the SelfCAD UX, first of all, is designed to go from simple to more advanced. So if you start on the left hand, you have a basic way of creating objects. And then you have another thing which will move on to do drawing, create objects through drawing, not using ready-made shapes through generators. But then we have more advanced generator, and then we have drawing features. And similar, it goes on from more simple to advanced. We have also the selection panel, how you select faces, vertices, and edges. The only one that has this simple cubic type selection. That's one part. So the basic layout is really easy to use. That's just the start point. That's basic UX. When it comes then, what we have done later is we have a concept that's called advanced settings. So one of the main complexity is, if you think about software like Blender, they have the most features from anyone else, but it's considered like a kitchen sink. It's really difficult to find something and do whatever it is. And the challenge is always to give something that is the most, basically in most use cases, you would use it in the most basic settings, but yet you still want to give some more specific use case examples and things more advanced settings. And also in some cases, like if you're a beginner, if you're a child, you don't want to be exposed to more advanced settings. It's too complex for you. I've spoken to many teachers which tell me they're really overwhelmed by software like Fusion 360 or others. It's just too complex and they have to decide which to teach and so on. So with SelfCAD, what we do is we have everything is the basic, and then almost every tool has a feature advanced settings. And if you go into advanced settings, this is how we show you the more advanced things. And that's basically kind of isolates the more advanced features from the simple features, which just simplifies it again. And the third aspect that we have is we have something called selection first. So this is a very big deal. This is a deal breaker basically compared to other software. So if you think about, we handle many different type of objects. You can have a mesh, you can have a surface, you can have a profile, and many different selections. Even the mesh itself, you can select an edge, a vertex, you can select a face, you can select a polygon, and they all have different behavior. So the way this is solved in most other software is you enter a tool. So let's say a simple tool, extrusion. Extrusion will behave differently if you extrude a profile or if you extrude a mesh. It's totally different. So how do they know what you extrude and what it's doing? So the way they do it is they have to give you different modes. So you have a mode, there's a profile mode or sketch mode, whatever name is being said, and then a different mode for meshes and so on and so forth, which really complicates the application. And then furthermore, each mode uses their own names and own concepts for how to do certain things. What SelfCAD is doing differently is we are selection first. So we tell you first to select the object before you enter the tool, and then we dynamically make the tool behave. So we have only one extrusion tool in the entire application. There's no different modes, there's only one mode. But if you select a profile, it will behave one way. And even in a profile itself, if the profile is coplanar, will behave one way. If it's not, it will behave differently. If it's a mesh, if it's a polygon, it's an edge, everything behaves differently. And this is what the way we have done is we simplified, we reduced the tools by, instead of having hundreds and hundreds of tools, we reduced it by, I haven't counted exactly, but probably, like just 30% or something like that, the total amount of tools. But internally, it's exactly the same amount. You'll have another tools. We just change them dynamically. And this is something that makes it much easier. It's also the same, we use the same concepts. So you have the same extrusion or the same revolve, the same loft. All of these type of stuff is behaving across all different things based on what you select. So you have a lot less to learn, and the behavior behaves the same, even though very often internally they're completely different tools. So that's basically the main thing why SelfCAD claims itself it's intuitive. It's not just a claim, it's actually the fact. And this is something, the feedback that we get, that people initially think we are kind of like Tinkercad, it looks so simple, but at the end they say we're like a lion in sheep's clothing. It's really designed so simple and simplified. Okay, so now let me talk about a little bit about the roadmap, so you get the idea of where we're coming from, what we have accomplished, and what you can expect going forward. So the first thing what we have accomplished is SelfCAD 2.0, and that's actually we've long moved since that version, but we keep that kind of like almost a slogan, SelfCAD 2.0, and that's a proof of concept. Why is that? Because what I just said before, the idea of making it intuitive and making the application that is a thing. So I only explained the intuitiveness and why it's easy to use. But the fact is that we had another objective also, that it must be robust. It shouldn't break. We have our own event system, thousands and thousands of events, and we can add more features. It shouldn't break. It must be really robust. And the second thing is it must be scalable, so we can add features and scale it. And what we have done when we designed SelfCAD 2.0, before that we had a few different versions and really struggled to come up with the final version. Once we came SelfCAD 2.0, we finally hit the jackpot. We had a version which is really robust. We have since added hundreds of tools and features without breaking anything. And we have scaled it with barely noticeable. It's all the same. It's embedded in menus and so on, really organized, which makes it really simple. And the SelfCAD 2.0 is the foundation, what allowed us later, which we'll talk later about the interactive tutorials. Because our application is so stable, we do not have to worry about backwards compatibility and any other issue in making tutorials. It's a significant investment that took about 2 years to develop interactive tutorials. And we were only able to do it because we have a really stable, robust infrastructure, which we call SelfCAD 2.0. So moving on now, the main objectives. That's kind of like still about the UX, but the main objectives that we had over here is that we wanted to focus on industry standards. So if you come from different applications, for example, Tinkercad, the problem often is that it's really great, and I really love it. It's great for teaching young kids to get familiar with 3D. But the problem is that once they graduate and once it's no longer accomplishing what they're trying to accomplish, they have to kind of unlearn and start from scratch. So we wanted to make sure that it's really industry standards and it's comparable 3D printing. We think about SketchUp. Some students use that as well, but I don't know the exact percentage, but I'm told that over 90% of the objects you design in SketchUp is not 3D printable. And then we wanted to add 3D rendering, as I said, because we had before that we have a big product design user base, and what Jennifer described about industry, and industry obviously needs 3D rendering. The fact is that 3D rendering is used a lot more than 3D printing. So we wanted to make sure it has everything. The next thing we wanted to make sure it's easy to learn, easy to use, and easy to teach. So easy to learn basically is the intuitiveness. Easy to use is also part of intuitiveness. And easy to teach is more about what Jennifer described is the idea of building this curriculum and interactive tutorials. The next thing is we wanted to focus that it's end-to-end tools without compromising design capabilities. And that means basically that often you see specific use cases. You have a lot of times a software that is really intuitive, really simple, and focuses only on the main use cases. So you can only use it for basic use case, and then you can only use it. One example is Tinkercad. It's really great and really simple, but only for young kids. That's an example of a specific use case, niche base, but it's compromises of capabilities, what you can do. We wanted to make sure that this is the foundation that you can do vertical alignment, that this can get you from starting from the beginning with the intuitive application. It looks really simple, and then move on onto really industrial design and any type product design, and still use the same application, everything, while it's still simple and still can do everything. So this was the main goal. So what we have done, I've shown the idea of this simplicity of the application, intuitiveness, and so on. But now in order to make it easy to learn and teach and so on, we have added interactive tutorials. So we have a lot of videos as well. So that's an official channel. I actually have my own channel. If someone's interested, they can contact me, which I have, I think, over 100 videos inspired by support and teaching people. So we do have a lot of good support and videos, but people often nowadays like to have hands-on experience. And interactive tutorials is something that they can really play it by themselves on their own pace and really do it and learn the applications physically. It's kind of like something sits next to you and tells you, now do this, now do this, now do that, and that's something. We actually also have a lot of videos on myself, on my channel, explaining interactive tutorials, so kind of combining both, adding the logic on top of it, what you see and what you learn, but then you have to practice yourself interactive tutorials. We have a self-paced learning, obviously, which is the idea of interactive tutorials, self-paced learning. And then we empower learners and educators to create their own learning material. So this is very powerful. The interactive tutorials is something that it's not programmed by us like every tutorial. We have created an infrastructure that any one of you can go and create a tutorial, record the tutorial, and share it. And you can share them privately or publicly. And the idea here is we have some schools that actually want to give tests for students. They tell them to design an interactive tutorial, and they can then basically review their work based on physically how they designed it. And so it's also, we had examples in industry use where we create interactive tutorials. I have specifically, personally trained a team of, this was the dentist that I said, they came from industry specific, they were a little bit confused in general CAD modeling. I created a few interactive tutorials for them and they loved it. And they used that to train their entire team. So interactive tutorials is something that takes you not just from the education part, but it takes you later on to actually use an industry to train people and so on. This is basically the idea. All of these interactive tutorials is a kind of the concept of self-paced learning or teaching and so on. But when it comes obviously to teachers in a classroom, that's a bit different. And we understand, obviously, we need to have professional curriculum and so on. And this is what we have Jennifer, which has all the credentials needed to qualify for this job. And that's basically what she's doing. I'll let her talk more about it, but the main idea, what she's doing is creating a full-fledged curriculum. It also incorporates a lot of the interactive tutorials, as she has shown before. It includes some videos, but it's mostly what an instructional designer does to organize them into proper curriculums for school, and she can talk more about that. And then the next thing is internships. So SelfCAD actually has experience with working with internships. The fun fact is that 90 or maybe 99% of the interactive tutorials are created by interns. That's basically the fact. And most of them are kids, the age you will be teaching, basically. And we have trained them. So obviously the way we train them is they create an interactive tutorial, come to us, we review it, and we give them feedback. The way it normally works, just from experience, personally, I worked with many interns. They are talented designers. They know exactly what they want to do, but often they may use a tool wrong, or they may use a tool that takes them, let's say, 20 steps when we have a specific tool that can do it in one step, or things like that. So we just guide them how to do it. And at the end of the day, if they work with us 2-3 months to do tutorials, they become really professionals. And you can watch SelfCAD's YouTube channel, which was created almost entirely by these interns, and the same interactive tutorials, and just to see what these kids actually are able to do after just a few tries with us. And when I say 2-3 months, it's not full time. They still studying in school, so it's kind of like an hour or two a day. And after just a short term working with us, they become really professionals. And the next thing is, which we're working with, is partnering with industries, is basically the example interactive tutorials can help partner with industry. They can train industry, but also in general of taking the professionals from SelfCAD and having them get interns into industries and so on. And that's all. But all of these, you can talk to Jennifer. That's basically her expertise. Okay, so now the obvious question everyone is asking, okay, so how do we compare to other software? So the main idea here is what we listed over here is Tinkercad, Fusion, and SketchUp, because all of these are often used in schools. So Tinkercad, I've already said before, a beginner friendly. It's really good for a beginner, but it's really limited. They have only one way of modeling. You can only do Boolean-based modeling, and SelfCAD, you have a variety, many different ways, all different standard ways of modeling. They compensate, though, to do things is a library of ready-made objects. It's very difficult. You cannot really import objects like from Thingiverse or these type of stuff. Most of the objects, it's limit on the complexity of the object. If the object is too big or too complex, you cannot do anything with it. So it's really limited what you can do. So it's good if you want to play with a ready-made object, and just kind of a little bit color it, or kind of subtract or add and things like that. That's where it's good. And as I said before, the main idea of Tinkercad is to introduce students to 3D space, which they're doing a great job on it. But that's basically all about. It comes to Fusion 360. Fusion 360 is a parametric modeling software, which sounds interesting for industrial design. But the fact is that most students are not going to take a job in industrial design. You have a much bigger potential to be a product designer or using 3D printing or any of these other industries that are not related to industrial design, and you're never going to use parametric modeling. And the complexity from the software is just too complex for them to learn. And then most of them fall out and actually don't use it. And it's difficult to learn, and then they end up not using it. It's also a software is a beginner software. It's not really robust. I'm being told by users that it has a lot of bugs, a lot of issues. There's a lot of difficulties using it. The main idea from Fusion 360 is kind of to jumpstart, to teach people the industry parametric modeling standards, so you can later go and buy a more advanced, complex software. But as I said, most students don't do it. So you're much better served with SelfCAD, which can help them along in any design career. As it comes to SketchUp, they are more a simple software, similar to SelfCAD in that sense, that they focus on simplicity, but it's specific for architectural design. And they also have a good library for architectural design. So for architectural students, this may be a good idea, but it's very difficult to design organic shapes and all different types of designs. It's very difficult to work with imported objects, and also most of the object design there is not 3D printable. So and obviously it's much more expensive than SelfCAD. So what I'm being told from SketchUp users that switched over to SelfCAD, that SelfCAD, they can do in SelfCAD natively without any plugins, much more than what you can do with SketchUp with many plugins, and each come with their own bugs and own stuff. So if you're going to teach a specific architectural school class, you may consider SketchUp better because that's industry standard. But if you're going to consider general purpose design, SelfCAD will get you much further. Okay, so with that, I would like to introduce you to pricing. I'll hand it over to Irish, but I just want to say one comment that SelfCAD is designed more to be industry broad. We're not like niche specific, and we're going to charge a lot. So we are the lowest in the industry because our focus is more that everyone should be able to use it and afford it. And on top of that, we give a much bigger discount for schools. So I'll hand it over to Irish.
Right. So hi again, everyone. Let me walk you through our pricing packages. Again, SelfCAD is a 3D modeling software that grows with you and your students. They can use it throughout their elementary, middle school, high school years up until when they are actually in their 3D modeling careers. So we do have a free plan. It comes with the basic modeling tools, basic geometry selection and editing, and interactive tutorials. And we also have standard pricing, SelfCAD Pro at 139.99 per user per year. So it comes with all of the free features, advanced modeling tools, and rendering. Our special offer for schools is what we're calling the early adopter package. So it comes with everything that SelfCAD Pro has to offer, along with the STEM curriculum that's valued at 1,800, web-based teacher training valued at 800 per teacher, off-the-shelf learning materials, and of course your access to the app. And it starts at 69.99 per user per year. And if you get 100 and up licenses, it only comes at 25 per user per year. And since this is an early adopter package, we're only offering it for a limited time and only for the first 50 schools who engage with us from this LinkedIn Live. So again, that's only the first 50 schools who engage with us from this LinkedIn Live, and this is everything that comes with it. So let me give you more details. We also have a license management portal. This is where teachers and admin can assign and reassign licenses to students so that only one person basically manages all of the accounts and it doesn't have to be chaotic. And here are some of the materials that we have. This is just a preview. We have off the shelf learning materials for teachers. We also have an implementation plan that's ready for you. And we're running internships that are not actually exclusive to the summer season. We have internships going on up until now. So if you want to grab your slot, just please make sure to book a call or email Jennifer Christian, our instructional designer, to reserve your early adopter slot. And yeah, we are now taking questions. Before we wrap up, let me go ahead and check some of the comments. We have Marcy here saying that it would be wonderful to create a community project slash collaboration application. So yeah, any thoughts on that, Aaron, Jennifer?
Yes, I've already kind of thought about what the community outreach would look like. And for right now, we're doing the internship projects and we're doing some maybe mini challenges. And there are some other things that we have in the work for community outreach. So if you have any suggestions or any thoughts that you want to start incorporating into your district, I'm open to all of it. So please reach out to me.
And yeah, I'm not seeing any other comments for now. So does anybody else have any questions? Please feel free to send them in the chat. And if you're watching the replay, please also feel free to send them in the chat. We'll respond to you and we'll connect with you. Um, so yeah, if there aren't any other comments or questions, perhaps Aaron, Jennifer, you could share a few words to wrap up.
Yes, okay. So I would like to say, first of all, thank you everyone for joining. And I would like to say one other thing that SelfCAD is a relatively startup. I mean, we have been in business for now a few years and we have quite many schools, but in a sense, compared to these bigger companies, we relatively new. And with that comes a lot of benefits as well. So we have the best customer support. The feedback that we get is 100% positive. We support, I mentioned before, Irish can share that my YouTube channel, which I have many videos, almost all inspired by support questions. I personally monitor support as well, but mostly we have Igor monitors, and the entire team is dedicated to making sure everything is good. And we have actually been developed through support. So because we are a smaller company, we didn't have the outreach, the resources to do the extensive research others are doing. So we actually build it by working with community. So we have from day one worked with our community and get feedback and work with them. And we are considered now, based on the feedback we're getting, one of the most robust 3D CAD software out there. So there's basically no bugs. And if anyone finds a bug, it's fixed immediately, but we haven't seen any, I mean, we may occasionally get some suggestions, but as far as in terms of bugs, something breaking or not working, it's maybe once every few months we can get something, but we basically down to none. And that's an achievement that very few CAD software, if any, can accomplish that. The other thing also that comes with that is the same idea when working with Jennifer. So we have this curriculum, which is relatively new, and Jennifer is currently helping specific schools to do their needs and so on. So we're not a big conglomerate yet and moving out and pushing stuff. We are happy to work with community. We have experience of training people. As I said before, we train students, and we are always happy to get feedback. We give feedback, support for people, even the people using our free version. And that's our way of connecting with industry and just giving support. We don't look if you're paid or not. We help everyone. And we helped a lot direct email, but we also monitor other channels, like we have people asking questions on Reddit or any place else. And at the end of the day, you are in good hands. And I hope you join us. And thank you.
Jennifer?
Yeah, thank you all for attending. I know you guys are busy and we just really appreciate you taking the time to listen to our presentation. Again, please don't hesitate to reach out. Give me all of your questions. Give me all of your suggestions. We really look forward to your feedback. Thank you.
All right. Thank you so much for joining us, everyone, and we hope you have a great day ahead.
Bye.